Hello Legacy Savers. So today we're going to look at section 5.2, which is on direct variation. Some materials you're going to want to have with you, some notes, a pen or a pencil, and you probably will need a calculator today. So this video is going to focus on how to identify direct variation and also write an equation that represents a direct variation relationship. So first of all, what is direct variation? So direct variation is a relationship between numbers or quantities that can be represented by a function in the form y equals kx. Now, that is going to be the main point that we're going to want today. Y equals k times x. Now, a constant of variation, this is the coefficient of x, aka the number in front. Of x. So in this case, it's always going to be k. So if they say find the coefficient, the constant of variation, we're going to want to find k. So first things first, we want to see how to identify a direct variation relationship. So I have these two examples. So they say, does the equation represent a direct variation? If so, find the constant of variation. So I have 7y equals 2x. What they want us to do is figure out, can I get these to look like this? Y equals some number times x. So we want to get y alone. That's the goal. So first of all, let's get y alone on example A. So I'm going to divide by 7 on both sides, it looks like. And I get y equals 2/7 x. Now, I'm going to look here. Y is alone. And I have a number. It's a fraction, but that doesn't matter. A number in front of x. And I don't have anything added to it or subtracted. So this is a direct variation. So it's yes, direct. And then they are asking, what is k? So k is the number in front of your x. So I know that k must be equal to 2/7. Now, let's look at B. So I want y alone. I'm going to subtract 4x from both sides. And I will get 3y equals 8 minus 4x. Now, I need y alone. So I'm going to divide by 3, and I get y equals 8 divided by 3 is 8/3, and minus 4/3 x. Now I put that 3 under both of them just so I can see the number in front of x. But one thing special about this one, notice how I have something being added on. That can't happen in a direct variation situation. So this guy is a no. I can never have anything added to it or subtracted from the x. Otherwise, we do not have a direct variation relationship. So, writing a direct variation equation. So this one, we get to assume that we have a direct variation. So they say, suppose y varies with x, and y equals 35 when x equals 5. What direct variation equation relates x and y? Then, once we find that, what is the value of y when x is 9? So we're going to use that equation again. Y equals kx. So they told me y was 35. So I'm going to put that in for y. Don't know what k is. That's what we're going to try to find here. And x, they told me, is 5. So I'm going to put 5 there. So now, what I want to do is solve for that constant of variation. So I'm going to divide by 5 on both sides so I can get k alone. So I'm going to get 35 divided by 5, and that's going to give me a 7. So I know k is equal to 7. So what I'm going to do is I'm going to take that 7 and put it in for k to get my equation. So I get y equals 7x. That is the first answer. Now, number 2, the second part to this equation or problem. They want me to know what is the value of y when x is 9. So what I'm going to take that 9, pop it in for x. So I'm going to get y equals 7 times 9. 7 times 9, 63. Those are my 2 answers that they were looking for. Let's try this again. Let's try a new problem like this. So, writing another one, we say y varies with x and y is 10 when x is negative 2. What is the direct variation equation that relates x and y? What is the value of y when x is negative 15? So, just like last time, I have 2 parts to this question. So, let's start out with y equals kx. I know what y is. Looked like y was 10. So, go and pop that in there. Don't know what k is, but I do know x. He is negative 2. So, solve for x, or solve for k, excuse me. And I am going to get negative 5 equals k. So I'm going to take that and pop it in for the k up here. So I get y equals negative 5x. For the first part. Now, just like last time, they want to know what is the value of y when x equals negative 15. So I'm going to take that negative 15 and put it in for x. So I have y equals negative 5 times negative 15. So negative 5 times a negative 15 is going to give me a positive, and 5 times 15 is 75. So I know y must be 75 at that point. Now, final thing. Do the relationships I have here very directly. Now, direct variation means if something is going up, the other thing related to it is also going up. So if you think about, let's say, a recipe, and I know for each cup of sugar I have to add, I'm going to add 2 cups of flour. So I know that if I add 2 cups of sugar, I'm going to add 4 cups of flour. Notice how every time I add 1 more cup of sugar, I have to add more cups of flour. So they go up together. So we want to see, do they ever go up together? And is the ratio or the change between the two the same? So we have the number of ounces of cereal and the number of calories the cereal contains. Now, if you've ever looked at the cereal box, on the side, the calories is always based on how many ounces of cereal you're having. So as my number of ounces goes up, let's say 5 ounces goes to 7, my calories are also going to go which way? Up or down? Well, they better go up. As I keep eating more cereal, the calories in there should go up. So this is a direct variation. And the reason for it, both go up. They're directly related. So let's look at this one. The time it takes to travel a certain distance and the rate at which you travel. So time that takes to travel a certain distance. So it's like 2 hours. And the rate at which you travel, which the rate is like 60 miles an hour. So let's think about this though. If I travel at 30 miles an hour, just off to the side, kind of scratch paper idea here. If I travel at 30 miles an hour for 2 hours, it's going to take me 60 miles, right? Or I could cover that though if let's say I increase to 60 miles per hour. How long is it going to take me to get to 60 miles? It's going to take me only 1 hour. So think about it. The time is going to go down. So my time is going to go down as my rate goes up. Now, that's not direct variation. They have to go in the same way. So time would have to go up as rate goes up. So this is not direct variation. The reason? Time goes down as rate goes up. That's the end of the notes. See you later, Savers.